So lesson 7.5, still going with module 7. And you can see our learning target for this lesson, which is determine the number of solutions. The learning target, I can identify the number of solutions of a linear equation in one variable by simplifying each side and comparing coefficients and constants. Okay, so just by looking at an equation, and comparing those coefficients and constants, we can identify how many solutions there are going to be, whether there are going to be no solutions, there's going to be one solution, or there's going to be infinite number of solutions. Okay, so if I look at, I've got some examples set up on the board over here, and just put this like this so you all can see. All right. So the solution to an equation is the value of the variable that makes the equation true. And some equations have one solution, while some equations have no solution. When this occurs, no value will make the equation true. Other equations may have infinitely many solutions. When this occurs, the equation is true for every value of the variable. So you can have no solution, you can have one solution, you can have infinite number of solutions. Okay, so no solution. That is like if I'm saying A is equal to B. I can't say 10 is equal to 11. It's not possible. Those are two different numbers altogether. So when I say A is equal to B, I'm just using the symbol. These are different variables. So therefore, there's no solution. Here's an example. If I say 3x plus 4 is equal to 3x, I know that using my properties of equality, I am going to have, subtract 3x, I'm going to get 4 is equal to 0. And that's how I get this example of 4 is equal to 0. Since 4 is not equal to 0, I mean, that's not possible. 4 is definitely not equal to 0. So since 4 is not equal to 0, okay, there's no solution. There is no solution. Okay, there's no solution in this case because 4 cannot be equal to 0. All right, now let's look at the next one where we have one solution. So if I was solving this, I would do opposite of multiplication is division. Division property of equality, I would divide both sides by 2 and I would get x, and 20 divided by 2, I would get 10. All right, so x is equal to 10. Since x is equal to 10, there is one solution. Okay, since x is equal to 10, there is one solution to this equation. Okay, now let's look at the last one. Okay, so I have 4x plus 2 and 4x plus 2. So basically, what am I getting over here? 4x minus 4x. And I am left with 2 is equal to 2. Right? Since 2 is equal to 2, any value that I give to x, so all values of x are going to be solutions. All values of x will be a solution. Okay, so that is why in this one we have infinite solutions over here. Okay, so this one, remember, x, if x is a 1, this is x is 1. I mean, it doesn't matter. Whatever value we use for x, in that case, you will get all values of x are going to give me a solution. So this has infinite solution. So that is the 3 different types. And so let's go ahead and do some examples. And we are going to solve for something and determine whether the equation has one solution, no solution, or infinitely many solutions. Okay, and so here we go. So if I give you an equation and I say 6x minus 3, All right. Plus 10. Okay, so 6x minus 3 plus 10 is equal to 2, 3x minus 4. 2, 3x minus 4. Okay, so here is my equation, and we are trying to see is this like no solution, one solution, or infinite solutions. Okay, so now we're going to use the distributive property and solve. So 6 times x gives me 6x minus 6 times 3 is 18. So positive times negative, I'm going to get minus 18 plus 10 is equal to, again, distributive property, 2 times 3 is 6 times x is x, and 2 times negative 4 is minus 8. Okay, so now when I look at this, I have 6x, and then I have minus 18 plus 10, and so that gives me opposite signs. So I am going to subtract the absolute values, and I end up with 6x minus 8 is equal to 6x minus 8. Okay, and then all I'm doing is I am going to, once I have combined the like terms, I'm going to subtract 6x from both sides. Okay, so I'm going to subtract 6x from both sides because I'm trying to get rid of this 6x and minus 6x. Okay, so I am left with negative 8 is equal to negative 8. Negative 8 is equal to negative 8. Now, if I look at that, I can already see that the equation negative 8 is equal to negative 8 is always going to be true. Okay, it's always going to have, it's always going to be true because any value can be substituted to make the equation true. I can make x anything and it will make my equation true. All right, so this one has infinite solutions like this one that we had done earlier on. There are infinite solutions to this equation. Okay, in order to check the solution, we can replace x with any value. Okay, so I'm going to check this. So as I said, negative 8 is equal to negative 8. So I am going to give any value to x. So let's say I'm just going to choose 4. Let's say x is equal to 4. You can give any value. Okay, and then replace that into the equation. So if I say 6x minus 3 plus 10 is equal to 2 times 3 times x minus 4, I am going to replace the x with 4. That's the value I'm choosing, but you can choose any value. Okay, so I'm going to replace with 4. This is 4 minus 3 plus 10 is equal to 2. 3 times 4 minus 4. Okay, so now when I simplify, I can do 6 times 4 minus 6 times 3, or I can just do what is 4 minus 3. 4 minus 3 is 1, and 1 times 6 is 6, and plus 10 is equal to 3 times 4 is 12, and 12 minus 4 is 8. So 2 times 8, and 6 plus 10 is 16. 2 times 8 is 16. So look, it is definitely going to be equal on both sides, and 16 is equal to 16. So it doesn't matter in that situation, whatever value I choose to put for x, I will still, it will always be correct. It'll always be true. All right. So this one definitely has infinite solutions. Let's do another example so that we can understand this concept. Okay. So if I give you 8, 4 minus 2x, 8, 4 minus 2x, okay, is equal to 4, and we have 3 minus 5x, okay, plus 4x. So let's say we have an equation written out like this, and we are seeing whether this equation has no solution, one solution, or infinite number of solutions, okay? So we are going to first write this equation like I did, and then we are going to use distributive property in order to solve it. So 4 times 8 is 32 minus 8 times 2, 16x, positive times negative gives me minus, is equal to 4 times 3 is 12, minus 4 times 5 is 20x, plus 4x. All right, so I've just used the distributive property here. And then I'm going to combine the like terms, and I get 32 minus 16x is equal to, then let's see what the like terms are over here. And I have opposite signs. I have minus 20x plus 4x. So I subtract 4 from 20, and I'm going to get 12 minus 20 minus 4 is how much? It is 16. So I get 16x. All right. And then I am going to use the addition property of equality, and I am going to add 16x on both sides. Okay. And this becomes 0. This becomes 0. And so then it says 32 is equal to 12. Can 32 be equal to 12? Absolutely not. Okay, so equation 3212 is never true because no values can be substituted to make the equation true. So this equation has no solution. No solution. Okay, because no values of x are going to make the equation true. So this is never a true, yeah, it is never true. Okay. And then let's talk about sometimes we can analyze equations to determine the number of solutions. And it is possible to determine the number of solutions to an equation without actually solving it. And the number of solutions to an equation can be found after each side has been simplified. So let me just show you. When I talk about an equation, and so let's say no solution, one solution, and infinite solutions. Okay, so I'm just going to do this so that you can see how to categorize. All right, so just make it into a table. And then if I have an equation, I'm going to look at the coefficients. Okay, and I'm going to look at the constants. I'm going to look at the constants. Okay, so let's do some examples, and then this will help guide us to know whether they're just like, without even just by solving one side, if we know whether there's going to be a solution, one solution, or infinite solutions. So let's say I do 6x plus 3. 6x plus 3 is equal to 6x plus, oops, let me do this over here, sorry. I'm supposed to have put this over here. Okay. All right. I got too much into this side. I should have put this a little bit more to the left. Okay, so this was an equation, coefficients, and constants. Okay, so 6x plus 3 is equal to, if I give you something like this, is equal to 6x plus 1. I'm just writing three different equations, okay? And then if I have 6x plus 3, 6x plus 3 is equal to 4x plus 1, 4x plus 1. And then if I have 6x plus 3 is equal to 6x plus 3. Okay, so if I'm looking at this, to see an equation where there are no solutions, hope you cannot see that glare on the screen. Okay, so if I look at the coefficients, what's happening in the first one? All right, in the first one, where it says 6x plus 3 and it says 6x plus 1, what's happening? The coefficient comes before the variable, right? So the 6x and the 6x, so the coefficients are the same. Okay, coefficients are the same. However, what is the constant? The constant over here is 3. The constant over here is 1. So the constants are different. Constants are different. Okay, coefficient is the same, but constants are different for those where there's no solution. All right, let's look at the one solution. In one solution, we are looking at the coefficients. So I have 6 over here and I have 4 over here. So I can see that my coefficients are different. My coefficients are different. Okay, my coefficients are different here. And the constant can be different or it can be the same. So this can be different or the same. Okay, so in this case it is different because I have 3 as a constant and I have 1 as a constant. So for one solution, my coefficients can be different, will be different, and the constant, they can be different or the same. Let's look at the infinite solutions. Okay, so what about the coefficients? Both of them are the same. All right, what about the constants? The constants are also the same. Okay, so this is same and this is same, and that gives you infinite solutions. So I just wanted you to look at that really quick. So once again, for no solution, the coefficients will be the same, but the constant will be different. For one solution, coefficients will be different, constants can be same or different. For infinite solutions, the coefficients are the same and the constants are the same. All right, so let's go ahead and solve a problem, and we are going to look at that and say if it has infinite many solutions or not. Okay, so if I give you a problem, and I say 6x minus x plus 4, 6x minus x plus 4 plus 2x is equal to, so we are going to see what numbers would complete the equation so that it has infinitely many solutions. Okay, so what times x, okay, what times x plus what constant, so what coefficient and what constant would actually make it an infinite solution. That's what we are trying to see over here. So when I have this, I'm going to write the equation and I'm going to combine the like terms. Okay, so I have 6x, I have minus 1x, so that is 5x, and then I have plus 2x, so 5 plus 2, that gives me 7x plus 4, right? 7x plus 4 is going to give me what x plus what coefficient in order to made this an equation that has infinitely many solutions. So we know that in an infinite solution equation, the coefficients and the constants must be the same on each side. So if I'm having 7x over here, this side also has to be 7x. If this is the constant is 4, the constant has to be a 4 also over there. So look, the infinite solutions, what we had done earlier. Okay, so if this is 7x plus 4, then on this side, we should have, what is my coefficient? 7. Of course, the variable is the same, and plus, what's my constant? 4. So when this is it, then I know that this is going to be one with infinite number of solutions. Okay, so 6x minus x plus 4 plus 2x is equal to 7x plus 4 is the equation with infinitely many solutions. Okay, let's do one last one. We're going to try to find one where, that the equation has no solution, So we are going to create one like that. All right. So if you remember, we had just talked about this. And for the one with no solution, we had just talked about this. All right. So what should happen to the coefficients and what should happen to the constant? What should they be the same, different, what? Okay. So we had talked about this. In this, the coefficients are the same for no solution and constant is different. Constant is different. Okay. So let's go to the problem, and we are going to create an equation with no solution. So if I have 3 times 2x plus 4, okay, minus x is equal to what coefficient times the variable and plus what constant. Okay, that's what we are trying to find. So we've written out the equation. We're going to use a distributive property first in order to solve this, and 3 times 2x gives me 6x plus 3 times 4 gives me 12 minus x, all right, is equal to what coefficient plus what constant. Okay, so we are now going to combine the like terms, and I know that 6x minus 1x gives me 5x plus 12 is equal to what coefficient plus what constant, because we're trying to make an equation that there is no solution. Okay, so we can do that. So 5x, in this case, we are going to create one because 5x plus 12 is equal to, it said what? We can have the same coefficient. So when I'm writing it out, I can have the same coefficient, 5x plus 12. Coefficient can be what? 5, because the coefficient has to be the same. So 5x plus constant has to be different. So I can write any number for the constant, because that's what we're just trying to complete the equation so that there are no solutions. So if I put a different constant, this is 12, let me put a different one, let's say plus 8. So now you can see that I have the same coefficient but a different constant. So therefore, this equation is going to not have any solution since they have the same coefficient and different constants. Okay, so basically this is what this lesson is, by identifying how many solutions there are of a linear equation in one variable by simplifying each side, and then we are comparing the coefficients and the constants. All right, have a fabulous day, everyone.